7.4, approximating square roots, on page 310 in your textbook. So we're going to learn about how to classify numbers and then also how to approximate square roots. So ones that aren't perfect square roots, we're going to figure out how to approximate what that is. So, vocabulary word, an irrational number is a number that cannot be written as the ratio of two integers. So if it's a decimal, it can neither repeat nor end. So for example, if I have 0.25, that is not an irrational number because it ends. But sometimes, like if you do 1 divided by 3 in your calculator, you'll get 0.33333333333. Well, that's a repeating number, so it cannot be an irrational number. If you type in the pi digit, though, in your calculator, it'll give you 3.14159, and then I think it's like 2653 or something like that. It'll keep going, and it will never have a pattern to it. So an irrational number can never have a pattern to it, and it can never end. So if you can write it with the repeating symbol above it, it's not an irrational number. Okay, so the square root of any whole number that is not a perfect square is going to be irrational. So for example, the square root of 2, you can't find an exact answer for the square root of 2. When you plug that into a calculator, it's going to give you a decimal that goes on and on forever, and it's never going to have a pattern to it. The cube root of any integer that is not a perfect cube is also irrational. And we're going to learn how to approximate what they're going to be. All right, so real numbers. Real numbers are like everything that we deal with in this class. So real numbers encompass everything. Now, there are things called imaginary numbers. We won't get to those in this course, and you also won't get to them in algebra either. But we have real numbers. And within real numbers, we could either have irrational numbers, so those are numbers that are never going to have a pattern to them. So pi, the square root of 2, the cube root of 7, the square root of 2, 2 pi, all of those are irrational. But the opposite of irrational would be rational. So rational would be any number that can either be written as a fraction, or it can be written as a decimal that ends, or it can be written as a decimal with a repeating symbol above it. So 1/2, 2/3, 2.25, or 0.3 with the repeating sign above it. That repeating sign means that the 0.3 goes on and on and on and on and on. So within rational numbers, you could have fractions, decimals, but you could also have integers. Integers are going to be any numbers that you are counting with. So it could be -1, -2, -3. It could be positive negative numbers. It could be negative numbers. Any of those are going to be our integers. Whole numbers would also then include 0 as well. And whereas natural numbers are also going to be just the numbers that you count with. So 1, 2, 3, 4, 5, and so forth. So natural numbers, you're going to think about those as being the ones that you would just count with. So think about back to kindergarten when you learned to count. Those are considered natural numbers. So it's just a way to classify. So we want to classify each of these. So we have the square root of 12. Well, the square root of 12 we know is not a perfect square because 3 squared is 9 and 4 squared is 16, and it's between those two, and there's no other whole numbers between it. So I know that this is going to be irrational. Any square root that you can't take a perfect square root of is always going to be irrational. The next one is 0.25 repeating, and it's got a repeating sign over the 0.25. 0.25 repeating is going to be a rational number, because it is a decimal that can be written with a repeating sign. The square root of 9, well, the square root of 9 is 3. So the square root of 9 is an integer, which also means it is a rational number. If you look back up here, if it is an integer, that also fits in the bigger picture of a rational number. All right, the next one is 72 over 4. That's a fraction, 72 over 4. So that is, well, if we do 72 divided by 4, let's see what we get. 4 goes into 7 one time, and then 4 goes into 32 8 times. So it actually simplifies to 18, which means it is a natural number. It is a whole number. It is an integer. And it is a rational number. So If it fits into this one, that means it fits into every single one of them. So think about this circle is also in all the other 4. So because it is a natural number, it means it's all 4 of those. If it were an integer, it would need to be an integer and rational because integer is also in rational. So this gives you kind of a classification to see which one it's going to be. And then pi is an irrational number because it never has a pattern, it never repeats. Okay, so the next one, 0.1212212222. There's never going to be a pattern where you can say it's repeating. Well, we can see a pattern, but the pattern is changing each time. How many 2's are there changes each time. So we know that this one is going to be irrational. The next one is the square root of 196. Well, if you look at your square root list, that is actually the number 14. So that means it is a natural number, which means it's a whole number, integer, and rational. And then the last one, we have the cube root of 2. That's kind of hard to see. Let me rewrite it. Cube root of 2. The cube root of 2 is not a whole number answer, so we know it is going to be irrational. Okay. All right. So our next section is we're estimating. So we have the square root of 71. We want to estimate that to the nearest integer. So let's think of our perfect square. 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. 71 would have to fit right in here. So is it going to be closer to 64 or is it closer to 81? What do you guys think? Well, we know it's going to be between 8 and 9. 71 is 7 away from 64, and it's 10 away from 81. So we could say it is approximately 8. So then it says make a table of numbers between 8 and 9 whose squares are close to 71. So if we do 8.3 times 8.3, we get 68.89. 8.4 times 8.4 gives us 70.56. 8.5 times 8.5 gives us 72.25. 8.6 times 8.6 gives me 73.96. So we want the one that's going to be closest to 71, which is going to be this one. So we could say it is approximately, and that symbol means approximately 8.4. So I can either use the words approximately or I can use these symbols to show it's approximately. So we can round it to the nearest whole number and we can round it to the nearest tenth as well. And again, all we're doing is once we know it's between 8 and 9, we started to pick numbers between 8 and 9, so 8.3, 8.4, and we squared each of those numbers to find the one that was closest to it. All right, so go ahead and try the next ones. These are each square roots. So we've got the square root of 8. So if we think about the square root of 8, 2 times 2 is 4, and 3 times 3 is 9. So it's pretty close between these two. It's going to be closer to this one, so we can say it is approximately 3. And then we would need to figure out how close to 3 it actually is. So we can start trying different numbers. So if we do 2.7 squared, for example, so that would be 2.7 times 2.7. That gives me 7.29. So 2.7 is 7.29. Man, sorry. 2.7 is 7.9. 2.8 times 2.8 will give me 7.84. So we're getting close. 2.9 times 2.9 will give me 8.41. So you can see the closest one would be our 2.8. Okay. So let's try number 5. So 3 times 3 is 9, and 4 times 4 is 16. So between 9 and 16, we can see it's going to be the closest to 16. So we can say it's approximately 4. And then we need to figure out how close to 4 it is. So let's try 3.7, for example. So if I do 3.7 times 3.7, that gives me 13.69. So that's a little above, so let me try a little bit below. So 3.6 times 3.6 gives me 10.8. So we can see the closest was 3.7. So you can see I'm able to find which one it is by just using my calculator and squaring decimals. I get closer and closer to it. Okay, so for 24, 4 times 4 is 16, and 5 times 5 is 25, so it's pretty close to that. So we're going to say it's approximately 5. But we know it's going to be a little bit less than that, so let's try 4.9. I'm sorry, my pen is really not doing well today. So 4.9 times 4.9 is 24.01. I don't think we're going to get closer to that, but let's try 4.8. 4.8 times 4.8 is 23.04. So we're definitely closest with 4.9. Okay. Now the number that I choose for the first one is based off of how close to it. 24 is really close to 25. So I know it's going to be really close to 5, which is why I chose 4.9 as my first one. So you're finding the approximate that's the closest to it. And 110, well, 10 times 10 is 100. 11 times 11 is 121. So we know that it's going to be approximately 10. That's the one that's closest to. And then we can try some different numbers. So what if I do 10.3 times 10.3? 10.3 times 10.3 gives me 106.09. So let's try 10.4 times 10.4. That gives me 108.16. We're getting closer. So 10.5 times 10.5 is 110.25, and that's for my 10.5, which would make it the closest one. So I am showing my work. I am showing that I'm finding the nearest ones. I'm writing down those calculations. Even though you're doing the calculations with your calculator, write down the calculations that you're doing so I can see how you came up with that approximation. So you should always have a couple ones to show that you have found the closest one to it. Okay. Now we need to know which number is greater, so being able to compare them. So we have 4 and 1/5, and we have the square root of 23. So without even using our calculator, I know that square root of 23 is going to be pretty close to the square root of 25, which is our perfect square. So it's going to be pretty close to 5. So we know that this one is going to be somewhere close to 5. Let's figure out approximately how close to 5. So if I do 4.8 times 4.8, that gives me 23.04 when I square it, which is going to be probably as close as I can get to it. So 4.8 is bigger than 4 and 1/5. So we know that this one is our bigger number. Try number 9 and 10. See if you can use the rationale of the work we've been doing up here to do number 9 and number 10. All right, so this is the square root of 10, and this is the square root of 5. So the square root of 10, well, 3 times 3 is 9, so it's just going to be a little bit more than 3. And the square root of 5, well, that's pretty close to 4. 2 times 2, so I can see that this one is going to be bigger. It's pretty close to 3, whereas this one's pretty close to 2. And then the last one, square root of 2 and 2. Well, square root of 2 compared to 2, well, if I have to take the square root of it, that's going to make that number significantly smaller. So I know that the other one has to be the bigger one. Okay, so we're going to skip 11. We're going to come down to this last section. Writing a repeating decimal as a fraction. So let a variable x equal the repeating decimal d. Write the equation x is equal to d. Multiply each side of the equation by 10 to some power to form a new equation where n is the number of repeating decimals. And then subtract the original equation from the new equation and solve. Okay, so in the interest of time, we're not going to get to this one today. So I'm going to pause the video and we're going to come back and there'll be a second video then that finishes up this lesson. So let's take a second to pause. Go ahead and write a summary over estimating what we did up here. So estimating your square roots. Go ahead and summarize right here. And then in the next video, then we'll go to this section because we're almost out of time for today's video.